Good morning, everybody. Black box called AI. It is this black box that has the capability to improve our lifespan by 2 to 3 years while cutting down roughly $10 trillion in healthcare costs globally through personalized medicine. This is the same black box that has the capacity to reduce energy usage, UK's national energy usage, by hopping 10%, by accurately predicting the demand and helping us rebalance the renewable supplies. And it is the same black box that we hate for manipulating individual voters in the race up to US presidential election and the Brexit vote. Who created this black box? We did. Why did we create it to be a black box? So let's understand the basics. Let's understand the fundamental tectonic shift that is driving this AI revolution or driving the fourth industrial revolution. We have been in this particular world where software has been stupid and silly. From where we are moving to the world where software is intelligent. We were in the world where software digitized the world into 0 and 1, into bits and bytes, to the world where the software actually understands, oh, those millions of pixels that just zipped through me, that was actually a picture of a cat, or that was actually a picture of a dog. Your software is intelligent. So what happened in this particular world? You had a programmer who wrote a program P to the best of his or her abilities, probably having 2, 3, 4 variables. Output Y is the function of 3 variables, 4 variables. And then we fed data into that particular program P, which we gave you a deterministic answer, right? That is the world that all of us are used to. If you give certain input to the program today, or if you give the certain input to the same program today 6 months down the line, you will get the same answer. What had changed? What had changed is you take your data, your zillions of data points D, and you feed that into the machine and tell the machine, hey, this is what the answer is. And the machine is able to find the relationship between those zillions of data points and the answer. And it could be a function of Y as the output as the function of 20 variables, 50 variables, 100 variables, which humanly for a programmer would not have been possible to program, right? And that is the fundamental shift that has happened. And that has happened for a reason. We wanted it to be more accurate, more predictive, for us to be able to take better decisions, or for us to be able to do better risk management, for us to be able to do better customer experience. It's just that this world is probabilistic. And what I mean by probabilistic is the output that it is giving you, it's saying this is the output with so much of confidence interval. And the output today and the output 6 months down the line might be different because more data has flown through the system. So what does that mean? The more complex the system, the more variables it could handle, it's likely to have more predictive power. That means you're likely to make more profit. You're probably able to manage your risks better. You'll probably able to have better customer experience. Linear regression, if you have taken statistics classes, you know linear regression, simple, less model complexity, but probably is less accurate. But as you go down and want to have deep neural network, extremely complex, but you will probably have much better accuracy. So let's add a y-axis to this particular chart. What happens? the more the complexity, the less is the interpretability. The more the black, less the transparency or less the white. So it's the trade-off that we are talking of. Linear regression, very easy to understand, but probably less accurate. Neural network, extremely highly performant, much better accuracy, much better predictive power, but much less interpretable. You can't look into what is happening inside. And that's the conundrum. So it will give you here you understand the model, but it doesn't give you the best results. Here you don't understand the model, but gives you the best results. Right? So how do you solve this particular conundrum? But before we jump in, let's understand, now that we have built a black box, why are we now so hell-bent on unlocking that particular black box? What's the reason? Why do we want to do it? So let's think of a bank. The name of the bank is We Love You, We Care For You. The bank has a customer called John. And John wants to apply for a loan. And this particular bank, let's assume, uses our beloved black box to take a decision. So the application goes into the black box, and the black box tells you there is 55% chance that this customer won't be able to repay. So what this bank decides? It basically declines the loan, as would happen in many of the situations. John has a question. Why did you decline my loan? And then you would have manager like Lisa, probably like many of you, who is not going to just use the model just because it is given to her. She is the lending business manager. She won't trust the model just because it is given to her. She wants to, first of all, get confidence that this model is actually giving the right answer, right? So she wants to understand, why did model recommend that and not something else? She wants to understand, when is the model right and when is the model not right? In other words, what are the limitations of that particular model? How robust it is, in what situations I should not use this particular model. And then if model is not behaving right, why is it not behaving right? Because that is the only way to improve the model, right? So from a manager's perspective, you want to first of all develop that trust into the model. And then you have Susan, who is the CEO. What keeps her awake at night is, hey, my team is using this all new technology. I hope that we are not creating any unintended harm to any of the stakeholders. That is what is keeping her awake at night. And there is somebody who doesn't sleep, the regulator, who is asking you, are you following the requirements? Right? So with all these stakeholders are looking for unlocking the black box. So let's try to understand a bit more on what is keeping Susan awake at night. How many decisions have been made about you today by AI? How many this week? How many in this year? Yesterday night, when I switched on my Netflix, it recommended me Indian movies and thriller movies. It has already profiled me. It has already made decision about me. I don't know how many of the ladies in this room, when you opened your Facebook yesterday, it made you forcefully to go through the advertisements for pregnancy tests or fertility clinics. It has already profiled you. Latino men or black men are less likely to repay the loan compared to white men. Adam is a better programmer than Eve. Black man is likely to be a repeat offender. It sounds racist, but these are actual some of the decisions made by some of the AI models. And those decisions are then driving whether you will get that interview call, or what will be the premium that you will pay for car insurance, or what will be your rating in your annual performance review. You get the sense of the gravity. So let's take an example, real life example. Amazon, Edinburgh, its engineering hub. They wanted to grow quickly, they wanted to recruit, but how do you go quickly and find the right people? So they built an ML model, fed the historic data, and the job of the model was to scout the web and find the profiles which fit their requirement. Model got onto the job, identified the right people, and threw it to the manager. These are the people you should recruit because they are the best people. When manager looked at it, they were all male. Because historically, all the recruitments or the existing people, it's representative of the tech industry, has been male dominated. So what they did, they made it gender neutral and sent the ML model again scouting the web. And the model returned and gave the recommendations. The same results. Why? Because what model has looked at is, although it's gender neutral, it has removed all the applicants who were graduated from all women's college, or who had won women's chess championship, or it preferred the profiles which had a masculine language. I captured, I executed, and that is how the resumes were sent. Amazon had to abort that particular ML model. Because what is happening is, yes, there is no bias in terms of you have given historically what has happened to the model, but if the model industrializes and perpetuates the historical bias, you are creating unfair outcome for some sections of the society and causing an unintentional harm. And that is where you want to look inside the model and see what is it that could be going wrong. And that is what is keeping Susan awake at night. The first one, build trust, we discussed. Lisa, she wants to first of all build trust with the model. We'll have to meet the regulatory requirement. And finally is the feedback loop, which will improve the model performance. So that's the reason we created the black box, but now we are very keen that we want to unlock it. But how do you unlock it? So the sweet spot is somewhere there, right? I want to have the most complex model, the most performant model, and I want it to be fully transparent. What is the easiest way? Easiest way is to use linear regression, right, which is sitting here, because that is the most transparent. This is your model. Black box models, data is going through it, prediction is coming out. So if you use the simplest of the model, is the easiest way. But then, are you getting the accuracy that you want? Probably not. You're restricting your data scientists for working on their best. And many times you might not have one model, you might have 2, 3 models working together to give you that particular output. So what's the solution? Solution is to create or build a surrogate model. Build a model outside of your black box model, and let's call it an explanatory model, which will replicate to the best possible extent how black box model is working or behaving, so that you're not restricting your data scientists from using the best of the technology with whatever complexity while you're trying to achieve the explanation. That would be ideal, right? And then it also could have the feedback loop. As we understand the explanation, oh, there is actually a bias, we need to improve this particular thing, or this is not working. And what is the next thing? Can we really create a surrogate model that can explain everything into the black box model? If yes, why have the black box model, right? Let's have this model which can anyway replicate everything that the black box model is doing. So how do you overcome that situation? So what we call as local interpretability. So let's take an example. It's a model which is trained to predict the value of a second-hand car. Now your black box model is taking into consideration lots of parameters, the mileage, the make, number of ownership changes, any accident history, so many different parameters that the model has to look at. But if you narrow down your thing into one specific car that you want to get the value out of, then it's likely that the mileage that the car has driven will determine the value. So you basically narrow down on the output that you are going to look at and try to predict that using your explanatory model. And there are different ways of doing that. You have different models like Lime, like SHAP to do this particular thing. I will not get into all those details. But if simple things, if you have to remember, explanation, surrogate model, and the local interpretability, that is what is slowly helping us open or unlock the black box. So when you unlock, what is it that the model is explaining to you? What is it that model telling you? What is inside? So it is telling you why and not how. How is the complex mathematical equation? We can't comprehend it, and that's the reason we asked machine to do it. But it should tell you what. So let's assume you're using machine learning model to predict the value of a property, a residential property. So it should be able to tell you, hey, I have determined or I have suggested this is the value of this property because it has been driven by the value of the property in the locality, and that is one of the most important feature that I have used in taking that particular decision. Or the size of the area has been the next important thing. It could be distance to the school, it could be proximity to the park. And you know what? The crime rate in the area has made me reduce the value of that particular property. So it is basically telling you, I've taken this decision, these are the criteria, and this is the relative importance of that particular criteria. Right? So this is what the model is telling you. But what did we say? We had different stakeholders, and every stakeholder doesn't want to have this specific view. Right? Each one of them, we're looking at it differently. So you may want to have this output, but then translate it into the language, into the output that each of the stakeholder is looking for. Because your John, why my loan was declined, is probably looking for an answer, but in a different way compared to what Lisa was looking for, and very different what Susan is looking for. And finally, degree of interpretability. That means what level of interpretability you want to have for which models will be determined by your risk appetite and your stakeholder needs. And what I mean by that is, yes, if it is a lending model or any model which has societal implications, be it criminal justice, be it lending, be it healthcare decisions, probably you want to have much higher interpretability. But if it is a decision about cash flow forecast for your finance department, your needs might be different. Right? You might not need the same level of interpretability. Your stakeholders are going to be different. So, which models, what level of interpretability is your policy decision? So to sum it up, oops, that's the wrong slide. So to sum it up, AI is giving us superhuman powers. It is making us Superman, Superwoman, Spider-Man, and I think we need to use that power with great responsibility, and explainability is just one aspect of it. Thank you. Thank you.
Thank you very much. We've got time for some questions. So, who would like to ask a question to Abhi or make a comment on what you've heard.
I'm Longley, I'm with the Royal Society of the Arts. Thank you for your presentation. Would you be able to tell us a little bit about how you are taking this responsibility forward within Lloyds Banking Group?
So we have a responsible AI group which is set up, which is basically thinking through the variety of aspects that are involved in responsible AI, be it bias, be it fairness, be it explainability. So they are looking at each of those particular aspects, understanding the implications, understanding how we should up our game. That means how do we make our people capable, what kind of tools we should use to detect it and solve those particular problems. How do we get the stakeholders around the bank knowledgeable about this and driving the importance of it. So there is a very dedicated effort that is happening, not only in AI, but across the bank in terms of responsible business.
Hey, good morning. My name is Nuala. I'm from Pfizer. So I'm curious as to the governance around if the recipient of the decision of the model, so your loan officer, disagrees with the decision, but the owner of the model, let's say Susan, says actually that's how I want it to work. Who wins? What does that governance look like? Who decides if the model is right or if it's wrong?
So in this particular case, you are saying who is the recipient? Anybody in the business you are saying, for example?
So the people receiving the decisions from the model maybe say, no, the model's wrong, we need to iterate it, we need to update the logic. But actually the model might be right, that might be intended logic from leaders. So how do you decide, was it an unintended consequence of the model? Or actually is it doing what we want it to do and human beings just don't like the output?
So basically, if you look at AI as the evolution of decision making, right? When you deploy these models for decision making, you will actually have to make a big investment into the last mile. And the last mile in this particular case is rethinking of your decision making journey, right? Because the way you're going, it's not only that it is giving you more accurate results, it is probably allowing you to do 100 different scenarios rather than just one scenario that was earlier possible. Earlier, probably you had prediction once a week, now you can have 3 predictions thrice a day, right? So the entire decision making is changing. But before you actually productionize it, what companies do is they run a champion challenger phase. That is, the existing process is running, and in parallel, your new model is running, right? And as that part of the process, you are saying what is the result that the new model is giving, what is the result that the existing model is giving. And in that part of the process, number one, yes, it builds the trust, but it also starts telling you, hey, in my normal process, this is what the recommendation is, but in the new process, this is the recommendation. Have I not looked at something? If yes, I think I need to incorporate it. But the other answer could be, no, the prediction of this particular model is wrong, and hence, why is it wrong? How can I improve this, right? So only when all the stakeholders have got comfortable with that particular model, where the company will decide that, okay, I want to start using the new model. There is no need to be in a hurry to stop your existing process. And that is how then you take all the stakeholders along. I think it is, the way to look at it is how it is used to augment your decision making rather than to replace your decision making. That makes sense.
How do you validate the model over time? Because we know self-learning systems tend to may be able to build up their bias along the way when they go. So how do you make sure that after 3, 6, 9, 12 months, several years, the model still delivers, first of all, what it is intended, and second, how it adapts correctly to a changing environment?
A very, very valid point. I don't know if all of you understand the point that she's making. What happens is, this is a probabilistic model, which I talked of you earlier, right? And as the time passes, the way you have trained the model is fine, but the world around you had changed. And is the model still working right in the new environment? And typically what starts happening is the performance starts degrading. So you need to, unlike your deterministic models, which you, once you roll it out, you don't have to worry, it will just keep on running. For these probabilistic models, you will have to constantly keep monitoring the performance of this particular model. It could be the performance, it could be the way to check if there is new bias that is sort of creeping in. And there are tools for the ongoing monitoring of the performance for these particular models, which companies typically deploy centrally for monitoring the performance of these models. And if you see that the performance is degrading, you need to step in and say, hey, yes, you might have a training which is happening on an ongoing basis, but do you need to have an overhaul of the entire thing if the degradation is much bigger? But you need to have that feedback loop. It is extremely important, very, very valid point.
Very good presentation. My name's John Downing from Business Mix and Innovation Consultancy. It really got me thinking, listening to what you were talking about around, not only the predictive elements of the models, but also the risks of the models being hacked either by a rogue employee or by external operators. Do you feel there needs to be new or additional controls in place to try and detect and then protect these types of models where we don't fully understand what's happening?
Yes, I think extremely important to have your decision governance, the risk controls in place, not only in terms of the process, but actually embedded into the system, where possible, automated, and where possible, I mean, the example that you're talking of, who has the access to your code, for example? If it is a rogue employee who is accessing it, who has the access, who can change it? Is there a version control for that particular model? Is your audit able to check the versions have changed, who has made those particular changes? Has it suddenly changed the performance of the model? If yes, and if you have automated controls, it will be able to detect that particular thing very, very quickly. Absolutely right. We need to have the downside protection in place for safely scaling AI in the organization.
Abhi, thank you very much. Let's show appreciation to
Thank you. Thank you.